All right, and so now we are going to talk about what I put together and called solid fossil fuels, because it's really all about coal with like one little slide at the end about kerogen. So coal is from land plants and not marine organisms, from swamps where there's abundant trees and leaves, the anaerobic conditions, convert fallen trees and dead leaves into coal. But it also has to just like oil, it has to be like buried and it kind of like you can think of it as it lithifies into coal. And it doesn't turn into oil because it is the plant material instead of the animal material. Later, go. Um, and coal provides about 11% of the U.S. energy supply, 22% as electric power generation. So the formation of coal, so again, it needs to be buried with pressure, heat, and time. And so it turns from peat, which is pretty much just like dead plants that have fallen on the ground and are in the swamp. Although it gets kind of soily. This is like kind of like that. It's a little soily, but it's a more organic matter than soil. And then through time, it goes through these phases of coal. There are grades, actually. So lignite, subbituminous coal, then bituminous coal, and then anthracite. Anthracite's like the best. It's the one you want to go after. It's that real, like, shiny, pretty black rock. And it delivers the highest BTUs, which are British thermal units. Um, and so as it's going through the, what do I call it? It concentrates, the carbon concentrates, and so you actually get like less sediments and moisture and volatile components. They kind of, I don't know, I think of them as like they get squeezed out, and then the carbon gets like pure and pure carbon through each of these grades. And eventually it would turn into like graphite, diamonds, and stuff, or could. Don't know how often that actually happens. Um, Looking here, and then here's 0% carbon. So this is showing, yeah, so this is showing how um the carbon is kind of squeezing, like the other non-carbon things, elements are getting kind of squeezed out through this process. Coal reserves and resources. So this is coal reserves by country. The US actually has the most. And again, this is, what we know of. So I don't really know for sure if that's just because that we have the most or if we've just done a better job finding it. We have estimated US reserves of over 248 billion tons of recoverable oil and 4 trillion in total resources. Unfortunately, it is not clean to burn. I don't know if you've ever been to like anywhere where they're still like burning like coal in the trains. I know like Dollywood has one. Anyway, it stinks. There's sulfur. I'm sure in Kentucky we've all probably have like, I don't know, a grandfather or an uncle or something that worked in the coal mines. And of course you've heard of black lung and all of that. So kind of has some downsides. Let's see, coal can be converted into a liquid, into a gas as well with our engineering processes. Gas is low heat gas mix of carbon monoxide, methane, and hydrogen. Um, Produces about 15 to 30% of the heat as methane. Various technologies are being developed to increase the quality and production of this gas. In situ production projects also going on. So this is kind of back to that coal bed methane. Um, Here's just a map showing where there are coal beds by grade of coal, and then where there are coal mines. Environmentally, here's a picture of a coal ash spill. So coal ash is just the ashes left over after they burn it. It has a lot of heavy metals in it, so it's not very good stuff. And here's a picture after the reclamation for it, so how they were able to clean it up and turn it into a nice, pretty little pond area. And then here's a picture of another hazard of the coal catching fire. This is underground. I don't know where this picture was taken, but there's actually like a ghost town in Pennsylvania somewhere where a coal bed caught on fire and it has been burning for decades. And they just gave up on even trying to put it out. They're just letting it burn. It's been burning for literally decades. And so everybody left because you don't want to live above a burning coal mine. Coal mining hazards and environmental impact. So this graph here is showing the number of coal fatalities. So it's gone down because of, well, probably OSHA and a lot of increased safety measures. And this just kind of gives a list of oh, consequences of mining. Mines can collapse, black lung disease, cancer from radon gas, explosions. Um, and then sulfur creates sulfuric acid. Um, and there's a lot of pyrite associated with coal beds, and that's where the pyrite is what that gold. It's what they call fool's gold. But it has a lot of sulfur in it, and so when it gets weathered with the water, it turns into sulfuric acid. And then here's just a little bit about oil shales. Waxy solid called kerogen is what those are those heavy molecules we talked about, kind of like it hasn't been fully cracked or really like turned into good oil yet. But we have about 2 to 5 trillion barrels of shale oil. Um, Not yet cost effective to go after those. So this would definitely be in that resources category and not the reserves category. Um, it'd be something we would mine. It wouldn't flow. Actual amount of oil to be produced from shale is not clearly defined. So this is something we really don't know much about, really haven't tried to extract it. We just kind of know it's there and where some of the resources are currently. And that is it for fossil fuels.